The objective of this video is to understand how binary heaps work. Specifically, we'll look at a min heap. A min heap is a complete binary tree where each child is larger than its parent. Consequently, all the nodes under any given node will be less than or equal to the value of that node. Before we look at heaps, let's look at the array representation of a binary tree. An array representation of a binary tree is just a level-by-level traversal of that tree. Since any parent in a binary tree can only have two children, the indices of the children of any node n are given by 2n plus 1 and 2n plus 2. Conversely, the parent of the nth node is given by the floor value of n minus 1 by 2. Now let's look at the min heap, beginning at insertion. The one rule we have to keep in mind is that the parent is always smaller than the child in a min heap. So anytime we insert a value at the end, compare this new value to the parent. If the parent is greater, swap them. Repeat the same till we satisfy the rule. This is termed as shifting up. Let's insert a bunch of values. Now that we have built a min heap, let's see how to pop values from it. Remember, we followed that rule to ensure that we always had the least value at the top, like placing the best apple on top of a heap in a supermarket. After popping it, pick the last node and place it on top. Note, I am swapping the first and last value instead of removing it entirely because it will come in handy soon. Once we have placed the last node at the top, we have broken the rule, which says that the parent of any node is always less than or equal to the children. So to correct this, compare the value of the parent with the children and swap them. Continue till we satisfy the rule. This is called shifting down. Let's empty the heap. And that is how you insert and pop values from a heap. Now look at the resultant array. We have inadvertently sorted the given array in descending order. How? Remember, we always popped the least value of the given numbers and placed it at the end one by one, which is just sorting in descending order. A max heap is the same as a min heap, but any parent in a max heap is always larger than its children. Thank you, and do consider subscribing.